We're continuing in 2.4, number 6, and it says the height of a vertically moving object at time t measured in feet and time in seconds is given by this. Make it a little bit bigger for you in case it's hard to read. 3 plus 2 cosine of t over 1.2 to the t. And what's the instantaneous velocity at 2? So I need to find the derivative of that. I'm going to run out of room there, so let's pull in a sheet of paper. So h prime of t is going to be the derivative of 3, or 0, plus, now I have a quotient, so the derivative of the numerator. So the 2 hangs around. Derivative of cosine is negative sine t times the denominator minus derivative of the denominator, so that's going to be ln 1.2 times 1.2 to the t times the numerator, I'm getting off the paper there, over the denominator to the t squared. Okay, and then we're supposed to find this at t equal 2. The velocity at t equal 2. So I've got let's start with a fraction that we can do on this calculator, and we got negative 2 sine at 2 times 1.2 to the 2 minus ln of 1.2, close the ln, times 1.2 to the 2 times 2 cosine 2 over 1.2 to the 2, and I went, this quantity squared. Okay? And I get negative 1.157. Let's check that. And again, to check, we can go to the calculator and type in the original equation, 3 plus 2 cosine of x, close the parenthesis, all divided by, or just the 2 cosine x is divided by 1.2 to the t, 1.2 to the x. And if I push graph, and at 2, it looks like it has a negative about a little over 1 slope. Well, that's what we got. And we'll check it here. Second, calculate the slope at 2, and it says it's negative 1.157. Okay? So I did a check on that. Now they say, what is the object's acceleration at instant 2? So I have to take the derivative of the velocity. Oh my word. Let me clean this up a little bit. H prime of t equals, there's a 1.2 to the t, a 1.2 to the t in both of those parts of the numerator. So if I factored them out and canceled them with one of the 1.2 to the t's in the denominator, that would be gone, leaving 1.2 to the t in the denominator. There is a 2 in both of these, a negative 2 and a negative 2, so I can write negative 2, parenthesis, sine of t, took the negative out, so it's plus cosine t over 1.2 to the t. That's just cleaned up. Oh, I missed the ln of 1.2. ln of 1.2. ln 1.2 times that we factored out times, oh, and there is a 2 on that also. No, I took the 2's out, okay? That's over here. Okay, I think I got it all in there. So now I got to take the derivative of this to get the acceleration, the second derivative of the position. So a quotient rule. And all over 1.2 to the t squared. And derivative of the numerator times the denominator, that would be 1.2 to the t, minus derivative of the denominator, that's ln of 1.2 times 1.2 to the t, times the numerator, a negative 2 plus ln, running out of room, ln 1.2 cosine t. Okay? And now I still have to do the derivative of this numerator here, which is minus 2 times the quantity. So the minus 2 will hang on. And then I'll do the derivative of the inside. Derivative of sine is cosine t plus ln, that's times this thing, so that's going to hang around, ln of 1.2 times the derivative of cosine, which is negative sine t. And they want us to find that instantaneous acceleration also at 2. So now I got to plug 2 into this. I see a 1.2 to the t, I see a 1.2 to the t. Factoring those out, that will cancel one of these, so I'll make it a little simpler. And so let me rewrite this. There's a 2 in here, and there's a 2 here, so I've got, I'll write negative 2, and then I have cosine t minus ln 1.2 sine t plus ln 1.2 times sine, I took the 2 out and then 1.2 to the t out. That's in here. And I'm taking a minus out, so this is minus. My mistake, I'm factoring out a minus 2 from this, and that isn't minus, so that makes that minus. Minus ln 1.2 sine of t plus ln 1.2 cosine t over 1.2 to the t. Okay. So, so we got to go to uh, just regular screen. We can type in this. So we've got, let me see if I can move that up so we can see it and type it. So you can see it as I type it. Okay, so I have a fraction. Math, fraction, oh, numerator is -2 parenthesis cosine 2 close parenthesis minus ln 1.2 close that ln sine 1.2 close this sine of 2 close parenthesis minus ln 1.2 close that parenthesis times the quantity sine of 2 plus ln of 1.2 close parenthesis cosine of 2 and close that group. So I have a starting of the group, ending of the group, times an ln of 1.2. Yep. Over 1.2 to the 2. And I'm getting 1.019. That's for the second derivative. That's the acceleration. The first derivative at 2, did I ever do that? Do we have to do this at 2? Yes. I don't think I ever did it at 2 for the first derivative. And I'm going to have to graph that one here in just a sec. I don't need to, but I'm going to. So I'm going to put it in y2, and that one is a fraction. So I'm going to go fraction in the numerator. It's -2 parenthesis sine of x close parenthesis plus ln 1.2 close parenthesis cosine x close parenthesis over 1.2 to the x. Okay? So that's y2. And if I want to find y2, the first derivative at 2, I'm going to do y2 of 2. So I'm going to quit here and go vars, y variables, function y2 of 2. And it's going to tell me this answer is -1.157. Did I do that already? Nope. Oh, yes, I did up here. So I just did it twice. Luckily, I got the same answer. All right. And then I got this for the acceleration. I'm going to check that on the graph. So I'm going to go, first of all, plug in the original equation. 3 plus fraction 2 cosine x close parenthesis over 1.2 to the x. Okay? So now I've got both of these on. So here, so I go second, go to graph. So there's the original function. And they ask for the slope at 2. And it looks like it's -1 something, like we had. We'll check that in a sec. And then here's the first derivative. And we were supposed to find the slope of it at 2, and that looks like positive about 1, and that looks about right. So now let's check it by doing the derivative of the original graph. Second, calculate the slope at, and I'm using y1 because it says so up here, the slope at 2, enter, and it gives me the slope of 1.157. That checks. And now the slope of the second derivative, I think if I just push the down arrow, I'm on that one. And then I can go second, calculate 6, the slope. Oh, I need to go down. And now I can enter in 2, enter, and it says that slope is 1.019, which is what we have. So that's number 6, with the checking using the calculator. Okay. Let's do 7. F of x equals sine x times cotangent x. Use the product rule to find f prime. So derivative of the first times the second plus the derivative of the second. So derivative of cotangent is cosecant x, no, cosecant squared of x times the first. Okay? Now, that's the derivative. Now, if we could do some simplification here. And since this is cosine of x times cotangent, which is cosine x over sine x, not sine x over cosine x, which is tangent, minus cosecant squared is 1 over sine squared x times sine x. This sine would cancel one of these sines. So I have 1 over sine x and 1 over sine x, and I have cosine squared x minus 1 over sine x. Now, 1 minus cosine squared x is sine squared, you might remember, or sine squared plus cosine squared is 1. So this is the negative of this. We have a negative 1 instead of a plus 1. We have a positive cosine instead of negative. So this is just negative sine squared x over sine x, which is negative sine x. Okay. So the derivative of this was negative sine x. Now, that was A. I did more than I needed to, but I did the simplification. It says just get the product rule. So that could have been done right up here or even right up there. Oops. This is a plus, and this is a, wait a minute. Oh, that was negative because of the cotangent was negative. So that's negative. So this is right. Okay, now, is it true that f of x equals cosine of x? Well, let's look at f of x. This is sine of x times cotangent of x, which is cosine x over sine x, and these cancel. So it looks like it's the cosine x. And This you can't do when the sine of x is 0, because this would have division by 0. This you can do with. So this is not exactly the same. This is very similar, except this one, sine cannot be 0. Here, we don't care what the sine is. So they're not true. It's false that they're exactly equal, but it's true that they're very similar, except when sine of 0, sine of x equals 0. When that happens, they're not. Okay? Now, C. Explain why the function you found is almost the opposite of the sine function. Yeah, opposite of the sine function, but not quite. It's the opposite of the sine function except for when sine is equal to 0. The opposite of sine function except for when sine of x equals 0. Okay? And now let's do 8. A big messy one. This is P of z. And the first thing we're supposed to do is find the derivative. So we have this quotient plus another term plus another term. So we got the sum rule, the big picture, but in the sum rule, I got to take the derivative of the quotient. So P of z is going to be a quotient rule plus the derivative of that, which I can do right now. 3 times e to the z derivative is going to be 3 hangs around because it's time. E to the z's derivative is e to the z, and the derivative of 1 is 0. So that's done. But we go back to this, and so it's derivative of the numerator times the denominator. So I'm going to put all that in there. That's z squared secant z plus 1. Derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. So this is z tangent z. Now the derivative of the numerator right here is a product. So now I have in here derivative of z times the second plus derivative of the tangent, which is times the first, and all of that is times that. Minus, now we got to do the derivative of the denominator, and that's a product. And so I've got and so derivative of z squared is 2z times secant z plus derivative of secant, which is secant z tangent z times z squared. Ran out of room over the denominator, z squared secant z plus 1. So that's the derivative. We're supposed to find out when this, and that's p prime of 0. Okay, if I can even follow my writing here, let's see if I can figure this out. See, the tangent of 0 is 0. So let's go and write it. We have something plus something times something plus 1 minus something plus something for the product rule here times z tangent z all over z squared secant z plus 1 squared. If I put in 0 into the tangent, I get 0. If I put 0 here, I get 0. And this is 1 over cosine of 0, which is 1 squared. So I get 1 times 0 is 0. So I got 0 plus 0 times this, and that's 0 times secant, which is 1. So that's 0. And then, so I've got 0 times 1, which is all 0. Then I've got 0 times secant z, which is 0, plus z squared times this stuff, which is 0, times 0 times tangent of 0, which is 0. So all of this is 0. So my numerator is 0 over my denominator is 0 times 1, which is 0 plus 1, 1 squared, which is 0. So that's the slope. So if I want to do the tangent line at a equals 0, it's going to be f prime at a times x minus a times plus f of a. F prime of a is 0 times x minus 0, which is 0, plus f of 0. So now I got to put 0 in the original. That would be 0 over 1. Oops, I forgot something here. I forgot to do plus 3e to the z. And e to the 0 is 1 times 3. So I got this plus 3, which is 3. So I got a slope of 3 times x minus 0 plus f of 0. And that would be 0 for this fraction, 3 for that, and 1 for that, which is 4. So I end up with 3x plus 4 as the equation of the tangent line. Y equals. Yeah, forgot this part. Okay. So at 0, is p increasing, decreasing, or neither? At 0, the equation of the tangent line is positive 3, so it's increasing. Okay. And that was 8.